Hey guys, this video we're going to look at conditional probability, which is the probability that an event occurs given that another event has already occurred. So it's got a little formula, and also this symbol is the vertical line right there. That's the symbol for conditional probability. It just means that what's the probability that that the second event happens given the first event happened. So you do the number of outcomes in common over the number of outcomes in the first event. So a single card is selected from a deck. Determine the probability that it is a club. Given that it was black. So again, looking back at that formula, it's the number of outcomes in common. So how many cards are both clubs and black? That would be 13. All club cards are black. And then over the number of outcomes in event 1, which is the given. So it's common over given. So given that it's black, how many cards are black? That would be 26. So it's 13 out of 26, which reduces to 1/2. All right, this time we're going to roll a die. Find the probability of getting a number less than 3 or equal to 2. Given that it's less than 5. All right, well, this kind of 4 is kind of weird because 2 is less than 3. Wait, no, I read that wrong. Less than or equal to 2, not 3. Where did I get a 3? All right, so let me change that. Less than or equal to 2. What I actually wrote there still equals the same, but that's okay. Less than or equal to 2, given less than 5. So how many numbers on a die are less than or equal to 2? That would be the numbers 1 and 2, which is 2 of them. Given it's less than 5, not equal to, so that includes 4, 3, 2, 1, which is 4 options, 2 out of 4, 1/2. Now I didn't express saying this, but if its number is less than 2, it's also less than 5. That's why I didn't really, remember we're looking at the combination of the two. So numbers that are less than 2 and less than 5 would just be numbers 1 and 2. Less than or equal to 2 and less than 5. All right, 2 dice are rolled. Find the probability that of an even sum given that the roll is a double. Probability of evens, given doubles. Okay, so how many doubles are even? That's what we're looking for first. So doubles would be like 1 and 1, 2 and 2, 3 and 3, 4, 4, 5, 5, and 6, 6. Those are doubles. So how many of those have an even sum? So add them up. We get 2, 4, 6, 8, 10, and 12. So all doubles have an even sum, so that's 6. Out of all the doubles, that's 6. 6 out of 6 is 1, or 100%. 2 marbles are drawn without replacement from a box containing 4 red, 3 white, 3 blue, 1 green. Find the probability that the second marble is white, given that the first marble is red. So this one's a little bit different. We don't actually need the formula for this one. We just need, we've got all these marbles. We take out a red one. So if we take out a red one, this is down to 3. And then that first thing happened. So now we're looking, what's the probability of it being white? So there are 3 whites left out of 1, 2, 9, 10 marbles. So that's it. That's 3 out of 10. Or you could say 0.3 or 30%. All right, so now we're going to look at some of these where they give you like a chart or a table. 200 patients who either had hip surgery or knee surgery were asked whether they were satisfied, dissatisfied, or neutral regarding the results of their surgery. The responses are given in the table. If one person from 200 patients surveyed is selected at random, determine the probability that the person was satisfied with the results. So that's it. It's just saying satisfied. There's no given. So there's 200 patients. 160 of them were satisfied. So that's 160 out of 200. That reduces to 16 out of 20, which reduces to 8 out of 10, or 4 out of 5. Or just say, you could say 0.8. Same situation. Determine the probability the person was satisfied with the results of the surgery given that they had knee surgery. So satisfied given knee surgery. So remember, when we start this, we're looking for the overlap of knee and satisfied is 70 out of the total of the first event, which is knee, which is 95. And you can reduce that. Divide by 5, you get 14 over 19. That should be it. Still the same situation. New question. Determine the probability the person was dissatisfied given they had hip surgery. So again, we're looking for the overlap. Dissatisfied with hip surgery. So that's 15 out of just the hip surgery piece. 105. And then that can reduce, divide by 5, we get 3 over 21, which reduces to 1/7. So one thing that you can do with these, it works on the last example as well as this one. Whatever the given is, you can highlight that row or column, whatever it is. So given they had knee surgery, you can highlight the entire knee surgery, and that's where your numbers are going to be coming from. We're going to look at the first thing out of the total. Same thing here. This one was for hip surgery, so you can highlight. And we looked at dissatisfied over the total. So you can highlight the given and pick your numbers from there. All right. Find the probability that a person had hip surgery given they were dissatisfied. So if we follow what we just said, again, we're looking for the overlap and then over dissatisfied, but if we follow what we said, given dissatisfied, you can highlight or circle the dissatisfied column, and then we're looking for hip surgery out of the total. So that's 15 out of 40, which can reduce to 3/8. Or you look at the intersection of hip and dissatisfied over just total dissatisfied, which, same thing. You get the same numbers, obviously. All right, so here's another table. just related to how old people are based off of, well, gender and all that stuff is factored into. Determine the probability that the person is male of all of them selected. So the probability being male, there's no given statement, so we have 145 total males out of 295 total. And then you can reduce that. If you type it in as a fraction on your calculator, it will automatically reduce. Same data, but this time we're looking for determine the probability that they are 15 to 64 years old. So just probability that they're between 15 and 64. So that's the category here. That's the only thing we're looking for, so we're going to take the total number of people in that age group out of the total people in the survey and reduce that. Doesn't reduce. I guess I don't need to rewrite it. Same situation. This time we're looking for that they are 15 to 64 given they're female. So given female means we can take just the female column. We're looking for 15 to 64 years old. So 15 to 64 given they are female. So we look at the overlap. Female 15 to 64 is 99 out of the total of females, which is 150. And that'll reduce a little bit. We can divide by 3 to get 33 over 50. And that's it. All right, same situation. It's probably that they're 65 or over given they are female. So given female, 65 or older would be 21 out of 150. Again, those can be divided by 3, so that's 7 out of 50. And that's it. Same situation. This time we're looking at probably that they're female given they're 0 to 14. So we're going to take the 0 to 14s, highlight or circle that, and then, because that's the only row we care about, now we're finding female. Female is 30 out of 61. And that does not reduce. Same situation, this is our last one. Find the probability that they are male given that they're between 15 and 64. So 15 to 64 is our given, that's the only row we care about. Find the probability they are male, that's 99 out of 198. And if you just look at the numbers here, that's 99 plus 99 to get 198, so that reduces to 1/2. That's it. Go ahead and get your homework from the Files tab, get it submitted, and post any comments or questions. See you next time.